All right, folks, this is my PowerPoint on my microcosm, one dirty mason jar. You know, the overview, I honestly didn't even know what a microcosm was until I took this course. In doing this project, I hope to see whether or not organisms would form and just how long they would last. I do think they could show us many things, for instance, what small organisms such as nymphs are hatching at a certain location in time. And this could also help us understand their population, how it's doing, and in that respect, its ability to be nutrients for other organisms such as trout, and how that affects their populations. The only really real way to see more or learn more is to have a larger microcosm. In my case, the life cycle was so quick it didn't allow me much time to see what could happen, in a larger time frame. And I think that's due to it being so micro, that I used a mason jar. I still think that something like a 20-gallon fish tank would be considered a microcosm. My hypothesis. My hypothesis is the organism formed. As that is done, the water would get cloudy and dirty due to the waste produced by organisms and having no way to get fresh water or air. Due to the lack of all this fresh supplies, if you will, eventually the organisms would consume all that is available and then starve and die. Methods and materials. Here in Emmett, Idaho, we have the Payette River running through town, and not 5 miles away, I was able to get to a public access point that had stagnant water pools beside the river that appears to have been created from high water that got disconnected once the water levels dropped. Below, you can see a Google Earth screenshot image, and the stagnant water runs through that tree line just north of the road. It's roughly comprised of 250 milliliters of sandy soil, 750 milliliters of water with an unknown small clump of aquatic vegetation. It was just enough I could grab with 3 fingers, my thumb and index and middle finger, and just plop it in the mason jar. It's contained in a Ball brand mason jar that's approximately 1 liter using a rubber seal and plastic lid. The microcosm ran from April 6th until May 17th, during which time the conditions experienced were mainly sunny to partly cloudy with few rainy and dark days. The sun was up significantly for most of the life of it, and on the windowsill that I had put it on, basically if the sun was up, it was hitting the microcosm. Observations and data. What I found was that it took time for significant life to form outside of an initial worm-like organism that I had immediately. It took roughly until day 9 for other organisms to come about. At day 18, there was numerous species of organisms, and my ability to see, there was 3 of them. Worm-like, nymph-like, and a microscopic dot-looking organism. As the population increased, the organic material began to dwindle and the water began to cloud with waste. The microorganisms were very active at all times, bumping about unless it was cold, which was rare as I recorded my data in the middle of the day. The nymphs and the worms never really moved when I was watching them unless I introduced stimuli through the method of tapping on the jar. Day 22, the nymphs grew significantly, with one growing significantly larger than the others. Day 27 brought extreme filth to the microcosm. Day 28, it all of a sudden became as if like a snap of a finger made it clean and clear. 33 showed all organisms but a few of the micros, and the largest nymph to be dead, and by day 36, all organisms were dead. The water was clear as it's ever been. Observation data. Following, you'll see some sketches I made. Week 1, it was hazy, the water was hazy, the dirt had settled, and the vegetation floated up top. It was hazy as the rest of the sediment was still settling, the finer sediment. Week 2, everything was clear. Wasn't really anything going on. As I said before, the worms and nymphs didn't move, so at this observation, I couldn't see the worm. Week 3, it's clear water again. Same on the nymph. Had the nymphs in there. Week 4, it was murky. One of the worms made its presence known. Week 5, it was murky. One of the nymphs was out and about with microorganisms all over. As you can also see, the vegetation has gotten smaller. Week 6, the nymphs all 3 were out on the glass, with the one significantly larger, and the microorganisms all over the place, with the vegetation very reduced in size. Week 7, vegetation's all but gone, water's clear, and the big nymph was kind of suspended, floating dead. Week 8 would have been next week. Major findings. What happened was what I hypothesized. After due time, lack of new necessary materials such as water, food, and oxygen caused the life that did grow to die. That exact reason, if it was a combination of all losses of everything, or if it was one specific, like say, if they had more food, they could have survived, I'm not going to be able to know. It also seemed that once life appeared, it took off pretty fast, leveled off shortly in population before dropping significantly. So the concepts I found to be in the microcosm are, number one, natural selection. The organisms are not intended to survive and flourish in the conditions that are set, that being an airtight mason jar. Therefore, nature had selected them to die. They'll last so long, and that's it. Concept number 2, ecological equivalent. The jar itself was an ecological equivalent of a stagnant stand of water. Life was still able to live, reproduce, grow, and die that would in a stagnant stand of water. Niche. The microcosm was such a specific and unique representation of the larger ecosystem, which for me is the Payette River. The river runs through my town. I fly fished it last year, and one spot of it, you might be in a nice wide open mouth, rocky bottom, clear water, fast moving water, no canopy. A couple hundred yards down, you have overtop canopy, slow moving water, and sandy bottom. So it's a pretty niche little part that I chose from. Further research, I'd like to conduct the experiment in a larger container, such as a fish tank with an aerator, to provide more oxygen while also not keeping it airtight. I wonder what changes would happen with extra room, an ability to have a much larger amount of feed, and fresh oxygen. I would like to know if it's going to follow the same path of a slow build, then a rapid increase, then a level off, and then a rapid decrease. I wonder if it'd be able to find and settle out on a stable population and be able to sustain over and over. I believe that microcosms can show the biodiversity of a biome and allow us to see what changes there could be seen from biome to biome. I especially think it'd be valuable in large water sources that cover multiple biomes, such as the Mississippi River. Because of its size and the ability to span across the country, north to south, we'd be able to see how the Bergman's rule and Allen's rule would apply to organisms along the great vast that is itself, the Mississippi River. I believe it would help us allow us to gain more knowledge on other species that are harder to really gain a lot of information on, such as migratory birds, because of their way of life. I feel like we'd be able to see some sort of difference in birds, that frequent in the northern part of Mississippi or, the southern part. And I think that would help us learn a bit more about, the great birds that are waterfowl. My references, got Google Earth and then our textbook. So, hope you enjoyed.